Okay, welcome to part three of modeling atoms. We just left off talking about the mass number, which is the atomic number plus the number of neutrons. So it's the number of protons plus the number of neutrons. That gives us our mass. Now, what happens if, let's see, the number of protons in each element can never change. So neon always has 10 protons. That is what makes it neon. So if we look up here at the periodic table again, neon has 10 protons. If it lost a proton, it's not neon anymore. It is now fluorine. If it gains a proton, it's not neon anymore. Now it's Na. Ooh, Na is a tough one. That is sodium. Um, so the proton is really what defines the element. But looking at neutrons, the number of neutrons can actually change. So that is what we call an isotope. So an isotope is um, an atom that has different number of neutrons. So here's some examples of oxygen. So we have oxygen 16, oxygen 17, and oxygen 18. So notice the protons are the exact same in each one of these types of oxygen, but the neutrons are a little bit different. So we have 8 neutrons, 9 neutrons, or 10 neutrons um, in that nucleus in the middle. Okay, they're all oxygen though, just the same. Notice the electrons surrounding it are still the same as well. So electrons are negative. They're always going to match up with the number of protons in a neutral atom. And so just the electrons will match up with the number of protons. The neutrons can change, and that's what makes it an isotope. Now you might be asking yourself, well, if the number of neutrons changes, does that change the mass of the atom? And yes, it does. So you will notice here we have oxygen 16, 17, and 18. That is the mass of each of those oxygens. So when we calculate atomic mass, we need to take into consideration the different masses of the different types of that element. So for example, if we're looking at bromine, we have bromine 81 and we have bromine 79. Now there's a little bit more, a little over 50% of the bromine that's in the universe is actually bromine 79. A little bit under 50% is bromine 81. And so when we do our calculations here, we take into consideration that percentage. Now, don't worry about this too much. We'll do a little introduction to this and probably a practice problem at some point in time. But this isn't super important that you know how to do this, but it's important that you know why the mass, how that mass is calculated and why there are all these decimal places after the atomic mass. And so the atomic mass of bromine is approximately 80 atomic mass units because it's approximately 50% bromine 81 and bromine 79. So when we look at chlorine, only about 25% of chlorine is chlorine 37, and over 75% of chlorine is chlorine 35. So the average atomic mass for chlorine is going to be closer to 35 if you take into consideration the abundance of that in the universe. Okay, we'll look at this more in depth later on, but this was an introduction to atoms, the internal structure of an atom, and the periodic table, and how to calculate atomic mass.